You can navigate through the text or the map. So for example, I clicked on distance now, and now distance is at the center, and then the most closely related concepts are again at the first level. There is another feature where I could go, let's say I'm looking at work in an inclined plane, but as a student I also want to know what work is like in another simple machine, for example, a wheel and axle. So I can change views, and now I am in work in a wheel and axle. So there is lateral navigation as well as vertical and horizontal navigation. The system keeps a log of everything that students click on, and again, they use this, they go to the system with a set of questions related to their design challenges and find information and apply it to their ongoing designs. I'm going to have to log in again to and then, as I said, there are simulations in the system. And here, students can actually change variables. They can change the ramp height, the ramp length, change the applied force. And once the force is at a particular level, the simulation starts working. Of course, I forgot to ask the system what measurements. So I can do all different kinds of measurements depending on what level, and this is up to the teacher and the students in any particular classroom. So I checked everything right now. So yeah, you get the idea. So students actually have a student notebook that we have designed that includes a set of tables where they can actually note down what happened to the different variables when they were running the simulation, as well as when they were running their hands-on experiments. So this will, we have like a 40 page, I think, student notebook where they can take down measurements and write down what happened during each of the experiments based on the data that they collected. And we also have a similar pulley simulation, which I can show if there is time later. So the CoMPASS, I mean, all these different technology tools are actually embedded within a design-based curriculum, like I said. And design activities actually are a great way to help students learn science, because students can really revisit the big ideas over and over. So for the Simple Machines unit, we have what we call the Can Lift Challenge. And for Forces and Motion, we have a Roller Coaster Challenge. So what happens in the Can Lift Challenge? Students are presented with a scenario where one of their teachers, and this is from a real school, it really happened, had a wrist injury, and it was difficult for her to lift heavy objects. And students are told that in order to help Mrs. Pelletier lift heavy things, you can use simple machines, but you build a scaled-down version of a device that will help her lift heavy things, and they use a 16 ounces can of food and 2 or maximum 3 simple machines to put together this device that can help her lift heavy things. And as they work on this overarching design challenge, there are several mini challenges for each of the simple machines, which are more like science investigations, both hands-on and simulated, that they undertake and learn more about each of the simple machines. And then at the end, they put this device together to help Mrs. Pelletier lift heavy things. So this whole unit takes about, like I said before, 6 to 8 weeks in a classroom. We have been working with about 4 schools in Connecticut and 8 in Wisconsin, and several students have used these materials over the last several years. And we've been through several cycles of design, enact the curriculum in the classroom, analyze the results, both in terms of student learning, teaching, teacher facilitation, as well as the curriculum materials. And we have redesigned the curriculum materials. Every year we go through a cycle of design and based on what we've found. Our teachers have been partners in the research, and as Sharon said, so far we've been able to pay our teachers to partner with us and come to a professional development workshop in the summer and really, be our partners, because they are the ones who are implementing this curriculum in the classroom. So in terms of how this plays out in the classroom, I think anything I say would be really very short, so and not as detailed as the videos will show you some of the things. So I have a lot of videos, and hopefully we can get through at least a few of them. So as I said before, we start with brainstorming, where students think about what they know and what they don't know.